Yeah, so in terms of the format, I guess, the idea is that everyone can pitch a project or two if they want to. The pitch should be like no more than 5 minutes, ideally like 1 to 2 minutes. To be like, what's the project? What do you plan to do in that week? And why is it important for Monty? People can ask short follow-up questions, but ideally we don't get into a deep discussion
Right.
for every pitch. And then after all the pitches, we'll form groups around like who's interested to team up. So we shouldn't have a project where there's just one person working on it. You should always find at least one other person
Okay.
up on it. And then, yeah, we can also have a group of 3.
And then you can also, I guess, sort of dabble in another project.
Yeah,
but you should have one main.
Yeah, you can help out on another project, but it should be just consulting.
Yeah.
Not actually writing code or something for them.
Right.
And then on Friday, I already sent out the calendar invite for it. We would do like we usually did with like focus weeks or hackathons. Every team does a short presentation, kind of showcasing what they did, why it was important, and yeah, kind of the progress they made in that week. And then Jeff, Celeste, and Terry will be the judges who deliberate on which team wins the trophies. And yeah, I added on that spreadsheet a second page that says how to win the prize, which with some basic categories, kind of similar to the last time. So there's best in show, most entertaining presentation. So like even if what you tried didn't work out, you can still make it a fun presentation.
Yeah.
Most ambitious, best execution, most exciting results, most impactful, makes community happiest, makes the team happiest, and most creative solution to problems that came up. It's just some broad categories. The prize is like a little trophy, so yeah, don't take it too serious, I guess. But yeah, it should be a fun little competition maybe at the end. Hopefully every team gets some fun results. Yeah, so that all makes sense.
Cool. Exciting.
Okay, and then yeah, there aren't really any ground rules on when you're allowed to work on it or how you're allowed to help people. Just don't sabotage other teams. But yeah, I think that's obvious. Hopefully. Okay, cool. Yeah, I guess yeah, Tristan, the TV is not gonna work out, right?
I couldn't get it to work.
Okay. All right, whatever team gets to get the TV to work.
Yeah,
it's a bonus point. Okay, should we just start?
Yeah.
We can, yeah, I guess just start at the top of the list, and then whenever someone wants to pitch that project, we pitch it, and if they think it's not that relevant anymore, we skip it.
Yeah, sounds good. And should we put the laptop kind of in between Jeremy and Tristan, and then people can stand at the front here, so they're kind of presenting.
In progress.
So they're presenting both the kind of the recording and the room.
Yeah, I was just thinking so that Rami can see us. But
Or you could just join the meeting from your laptop so that I could just hear you, and mute this one that's seeing the whole room. I mean, just to get the microphones.
What are you trying to solve?
I was just saying, I just didn't know how important it is that Rami sees everyone else when people are pitching.
Oh.
And that maybe it's easier. It's a bit like kind of the camera in the Numenta office was like sort of at the end of the room. Well, I guess it was a mix. I don't know.
Yeah, I guess whoever pitches can also just stand over here.
Okay. Yeah, that's a good idea.
See them.
Sounds good.
Right. Can you hear me well, Rami?
I hear you. Yeah, you're a little quieter, but I hear you.
Okay, so we just need to project.
Talk louder.
All right.
So first up is implement object behavior prototype.
Start. Okay, so yeah, this one is kind of, I thought it would be a real fun project for this focus week because it's very much about building a prototype in a short amount of time and not getting too deep into the weeds of it and not building anything perfect, but getting an idea of what the issues are with object behaviors. And especially since in the past research meetings, we've gotten a lot more concrete about how we would want to implement object behaviors. I feel like I have a pretty concrete idea now where I would start and how I would try to implement it. So it could be a great opportunity to just kind of test that idea, see if there are any holes in that logic, and plus get some, kind of first prototype of object behaviors working. I think the main issue with the proposal might be that the scope might be a bit big for a week, because it would also involve setting up a test bed and all of that, but it might be actually a good forcing function to set up the most minimal test bed and do the most minimal kind of first prototype of it. Yeah, that's my pitch.
Nice.
Yeah. Benefit the community.
Oh yeah, being able to model object behaviors will unlock tons of new applications. And yeah, it's kind of one of the 3 big milestones in the project, like compositional objects, object behaviors, and then manipulating the world. So I think the closer we get to object behaviors and modeling moving stuff, the more people can actually do with Monty. So yeah, I think it'll be super powerful once Monty has that capability. This week, we're not going to add that capability to Monty, but it would at least get us closer to having an idea of how we would add it.
And yeah, to your point, it's quite like a big scope, but we'll just the way this kind of week has panned out and stuff, we'll probably have at least one team with 3 people.
Yeah.
And that could be one of them.
Yeah, and again, it's quite like the moonshot kind of project, and not the kind of project like obviously if we want to add object behaviors to Monty, that'll be like a multi-month effort with multiple people working on it to get everything right. But this would be like a very quick prototype to get an idea of like scoping that effort, basically. Yeah.
Cool. Next up, draft a spec for the CMP, suggested by Jeremy.
Yeah, I mean, so my thinking here was, I mean, when you talk about a messaging protocol or protocol of any type, I think of something that has a spec that describes the behaviors of the system, the message format, and how it behaves. And I think it would be useful to have something more concrete, because make implementations of modules and stuff by ourselves in the community easier to do if we're only kind of matching a protocol. I thought it'd be useful to do that here where we're all in person and can talk about it and kind of get on the same page of what do we mean when we say we have a protocol? What does that look like? Yeah. So
what will be the kind of outcome of at the end of the week?
Like coming up with a spec, or at least a draft spec.
Like a written document?
Yeah. I know that like Tristan sort of started one, but like kind of filling in some more of the details of like what actually happens when you're doing voting or doing setting goals and stuff like that. Like what is the actual like nailing down the specifics of the protocol?
Yeah. And it could potentially then become part of the documentation or like a protocol in the code base.
Yep. So,
cool. Yeah, one thing to maybe think about is just obviously we want to make the most of like us being here in person and being able to collaborate in teams and stuff like that. I'm just wondering whether we could have kind of teams where it is one person with 1 or 2 collaborators, but only one person who's actually like doing the main work.
Like one person getting a lot of input from other people.
Yeah, because like it would still be making use of the fact that we're all here.
Yeah.
But just because I feel like we have a lot of nice ideas.
Yeah.
And some of them don't necessarily maybe need multiple people working on it.
Point, yeah.
And so like maybe that one, for example, if you were working on that, Jeremy, then like you could still get input from a few people and stuff. But so it wouldn't be like you're on your own. But yeah, it's just a thought as we're kind of going through them.
I'd be okay with that.
Cool.
Yeah, a project that naturally involves interaction with pretty much everyone.
Yeah.
Doesn't necessarily need to have multiple people full-time working on it.
Right. Kind of like I remember in a previous Numenta hackathon, I think Charmaine did like interviews of everyone or something like that. And so it's like it was kind of everyone and also just Charmaine.
Yeah.
Cool. That might make it easier as well in terms of the size of the teams, because otherwise basically have 3 projects, 2 3-person teams and 1 2-person team.
Yeah.
Like,
oh yeah, and by the way, if a 3-person team wins, then we can just order another trophy. Shouldn't be an issue. I just thought they're pretty heavy, so
yeah,
a bit much to get 3 trophies here and then.
And what do we do with the third one if
Yeah.
the 2-person winner?
Prototype emitting telemetry data. So right now, every time you want to do a visualization, you have to do bespoke artisanal changes to the entire Monty framework in order to get out the data that you want to visualize and put it in the right place and then build a visualization around it. That's fine, but the problem is then if you want to change it, you have to go back and again change a lot of Monty code. The example of this was Rami recently wanted to visualize some data, so we had to kind of punch a hole through the entire framework so that the data could come out of where it was being collected. We have the technology to not do that. It's basically, if you think of how logging works, you just say get a logger and then logging.info, and then out of band all those logs are magically collected into a spot, etc. The idea here is to make collecting telemetry data as well as snapshots, which would be a name for screen buffer that you want to visualize, for example, using the same pipeline as logging does. So the benefit for the community would be that this is a standard mechanism for selecting what data you want to visualize into your telemetry stream. The way this would work is just like in logging, you can turn on logging per module. You could turn on snapshots per module. So let's say you have my favorite learning module.py. You want to get snapshots just from that type of learning module, then you would configure Monty to have like trace level 4 snapshots for that module, and then those screen snapshots would just show up in your data stream, and then we will have handlers for to grab this data and put it in whatever format needs to be done. So like just save it binary onto disk or something like that. The other benefit is this is all will be streaming, so none of this would be like collecting all the data in RAM and then dumping it into disk or something like that. You would not be collecting this data in RAM, which is important as we increase number of learning modules. So it would be a standard way of collecting any sort of visualization data that you think you need. You would every time you write a new module, a new something, and you're like, hey, there is a snapshot thing that I might want to collect. You would write it out, like pick a snapshot like you would do logging. And then it also reduces the amount of code to modify when adding new telemetry collect, because you don't have to come up with a bespoke mechanism every time you have a new object in the code. You just like you don't invent logging every time you need to log something else. You just get a logger and you log. You would get the telemetry data thing and you would emit telemetry. That's the benefit for the community. Just way reduce cognitive load.
The existing buffer class, probably a lot of that could be removed after that was implemented. I'm just thinking, like, there's a couple things that, like the previous location, that it stores it.
Yeah, it still needs to store all of the observations so you can update the model at the end of an episode, but you could remove the stats.
Yeah, okay.
And so the goal, like if everything goes well, would be to have that integrated in Monty, or would that be kind of follow-up work from this week?
This is a prototype, so this would be a fork of Monty just demonstrating of how this works and that it does work, and probably grab like one visualization and rewrite it. All visualizations would have to be rewritten, so probably grab one visualization to rewrite it, accepting a data stream versus like this one JSON object that everybody expects.
Yeah, it's also interesting. You mentioned about it not going into RAM, so it just writes it directly to disk every time it stores something.
Yeah, just like logs.
Yeah,
It just get dumped.
I'm just wondering how much of a performance hit we're getting when we do detailed logging just from accumulating, image data. And,
as long as you have RAM, you don't get anything. But
Yeah.
but you can't run anything with detailed logging that's like more than 10 learning modules, is it?
part of that is, I think, the JSON file that gets stored. But so like maybe part of this would be, thinking about how we store the things like imaging data as well.
Just wondering if you could add filters. So
Yeah.
you know, in the same way you have logging levels, but
Yeah. You get filters. So like by default, all the snapshot would be trace level. So you'd have to turn off trace level for that module. But then you can also specify the name of the module. So you're like, I want like you could just specify I want these learning modules. And then even if you turn it on, you could add a filter. So I only want it to come from the first one and then ignore the other ones.
Right.
So there's always performance penalty for storing all the screen buffers that everybody ever sees. But it would be just like this standard way of dealing with it, like we already do with logs and metrics.
Cool.
Next one.
Next one, reference frame transformations library. This is the thing that Scott talked about, where all the data has metadata of what I'm trying to remember the current reality problem with it. So reference frames are detached, like the variables that store like a location or a pose are detached from reference frame that they are in. So in order to implement any transforms, you have to do two things. You have to do the appropriate combination of low-level operations, which are stored in like transform utils or whatever that Python class is called, and you have to remember which reference frame the variable represents. So you have to just pull that out of the air from your knowledge and then assemble it, and then you have a transform. As opposed to the alternative, which could be you have a variable and you just say 2 body coordinates, and then it just does it. Or you have 2 this sensor's coordinates and it just does it. Like the API is very different. So instead of like right now, we have to specify how to do transformations and we don't have all the information in scope. And the idea here is to have a reference frame transformations library that has all the scope attached to the variables that you're dealing with. And you stop specifying how, you just say what. I want to go from this sensor's reference frame to the body reference frame because I'm voting. And then in the assigned learning module, okay, I have this in a body reference frame, I want it in my reference frame. And you just say what you want and it just does it because all the data, its metadata is attached with the variable versus right now, every time you're trying to do that, you have to figure out the how. So
What do you mean by attached to the variable? Can you just write that? I'm missing it.
like imagine you have like a unit library. So you have meters.
Mhm.
So you're never handling like integer 7. You have a variable called meters with a value of 7, and you can do a dot 2 millimeters on it, and you'll get another variable that represents in millimeter. Like 2 millimeters would actually be probably serializing something into like 2 millimeters of string, and then you'd be like
Got it.
700 or something like that. Versus like you never actually have to worry about the units because it's always the correct thing. And you have a function where you expect millimeters, but you'll get this generic type of measurement. And then in your function, you just say whatever you get, 2 millimeters, to make sure you're in the right units that you care about. You don't care what number is in there. They'll give you the millimeters when you ask for millimeters.
You also
But
can
because it knows that it's represented in meters and I need to multiply by 1,000 or something like that.
you couldn't accidentally apply the wrong transform for something because you assume it's in a different reference frame than it is.
I mean, it's Python, so yeah, you absolutely can, but like it's easier not to make that mistake.
Yeah, and I mean, maybe we could talk about this more if we do it, but I feel like there's a few approaches you can take with this. Like Scott and I were talking about it recently, because I feel like this is the most kind of advanced and powerful approach, but probably requires some sort of graph representation of all the different like spaces and kind of how those are linked. One thing we could also do is just kind of attach metadata to each variable, and it would basically check for this, and it would also make it easier to kind of see, okay, what reference frame is it in and with respect to. But so it wouldn't solve the problem of like, oh, I just want it in body, but it would make it much easier to know what is the series of transformations you need to do to get that. And that would be just a case of kind of adding a bit of metadata and then changing the transformation functions a bit.
Yeah, especially because you can't always do each transformation if you don't have extra data, like what are the hypotheses. Without that you can't transform.
Yeah, and so I guess that's the potential danger of like in some ways it's kind of nice that we have to think about how you actually transform between these spaces, because it forces us to think like, is this reasonable? The problem is it's like the other extreme right now where it's like we don't even know what reference frame this is in. But like if you basically had in the same way the kind of robotics notation, the like it's this rep coordinate system with respect to this coordinate system, that could just be 2 pieces of metadata. So you could always like print that out if you wanted to know that about a variable. And then if you're transforming them, any transformation function would basically check, does the bottom prescript match the top prescript of the other matrix? If so, it's a valid transformation, and the output is going to be this prescript and this prescript. If they don't match, then it's invalid.
Yeah.
And like that would be simpler and already a lot better than what we have. But then the advantage of this full one is like when we start having like multi-jointed agents or something, it might get really complicated to say like, okay, wait, how do we go from finger to shoulder or something like that? And then maybe having an automated system to do that could help.
Yeah, we can talk about it in more
Right.
detail if that project.
So then it's wrapper for customizable interactive visualizations from Rami.
Yeah, I could pitch this one. I don't know if we're gonna do it, but I could pitch it. It's mostly that users would be able to mix and match visualizations now, because I have a pending PR for just having the widgets separated and talking to each other through pub subs or like topics, so they're not intertwined in the code itself. So what would happen is we could have a wrapper that goes over these visualizations, and you could bring in some visualization like Jose's visualization with mine and just put them in separate renders. And you wouldn't have duplicates in widgets that are required for these visualizations. For example, if you like Jose's visualization and mine, they both need a slider for the episode number or something like that, then the wrapper would be smart enough to know I'll just put one of them, put all the controls somewhere and just put all these visualizations together. So when you change one control, that control will just publish to the topics that are required. And all of them will change at the same time. So you can just design like the UI of whatever larger visualization that you want, and it will just bring in parts of visualizations from other sub visualizations, I guess. So that would be the idea. And we could use this in, presentations or whatever. You could just very quickly just define like a little piece of code that says, okay, I want this part from here, I want this part from here, and it will just make up one visualization where you can change them all with the same widget.
Nice. Yeah, no, that'd be cool. Yeah, I guess make Lego robot reproducible from Will.
Right. So this one is taking the Everything is Awesome Team's Lego robot and then replacing all of the Lego parts with 3D printed parts so that we can have a link to go and buy a bundle from some reputable 3D printing company to reproduce that robot exactly every time and not have to worry about all the bits that are difficult to get a hold of. So the project is essentially, because this would require like really long cycle times of going to a 3D printer and getting back, this would be just designing the 3D CAD pieces and doing as much of the pre-work as possible for getting everything ready so that we could start doing cycles with 3D printed parts after the hackathon week. The benefit to the community is that it's like the first robot that actually moves in the world autonomously and measures things, and it would be really exciting for the community to be able to like get that and play around with it and reproduce it and make it. Yeah.
Would you need experience with making CAD models to work on this project?
No, I don't have any. So we'd all be learning as we go. How difficult? It's just reference frames, right? We all have reference frame.
Yeah. Are you thinking of making the parts kind of pretty generic so people could configure them in different ways?
Yeah, so, like making it more modular as well might be like a good goal to have. Like getting the actual robot bits so that the original one works. But yeah, having it modular is really useful. So you can add multiple sensors and move it in different ways. Maybe have more axes of freedom.
Nice. Yeah, I'm just trying to remember the robot or whatever it's called. Because that's like an open source one from Hugging Face, I think.
The new little guy that
It's like an arm.
desk, or
It's this thing. It's called, I think it's technically called So Arm 100.
Yeah.
But it's like $300 or something like that. Or that's for 2 arms actually. I think the main issue, if I remember correctly, is I don't know if the camera is actually mounted on the arm. Like I think it's more at the base or something like that.
Okay.
But anyways, I'm just wondering, yeah, like it could be interesting. It is probably beyond the scope of a hackathon, but whether there's like a way for someone to implement Monty using this, and then that kind of like opens up other stuff. But
Yeah, I thought about that. These companies, like they seem to change their arm really fast, or then go out of business. It's difficult to like. I want to pick one where like in 5 years you could still do this. Like it's still, the CAD diagram is still available.
You have an idea how much it would cost?
It's pretty cheap. Like I was looking into the 3D printing, like the ones that just you send them a CAD file and then like a week later you get back the 3D printed objects, and it's like super cheap.
So people could, it wouldn't be like a huge thing for people to do.
No, especially with the simple one, it's just like a moving whatever. It wouldn't be too expensive. I think it would be cheaper than the Lego version.
Okay. All right, next one.
That's it. So if you crossed out, extract habitat sim wrappers as a separate project.
Okay, so habitat sim dependencies and Python requirements are holding us back from upgrading the rest of the Monty stuff. So the work here would be to create a separate, like a TDP simulator _ habitat project that would compartmentalize our habitat sim interactions, taking advantage of Jeremy's work that already isolated like the simulator protocol. So this would be putting the simulator protocol into like inter-process communication or some kind of network communication, and develop mechanism for controlling and interacting with a simulator that comes from a different project like TDP simulator habitat. The benefits to the community: Monty could be installed from PyPy, so pip install Monty, TDP Monty. Monty could use the latest Python. Monty could use the latest dependencies. Monty could run on ARM64 natively. It'd be much easier to measure Monty performance because Habitat Simulator would be in a separate process, completely separate thing. So whatever you're measuring on Monty, you're just measuring Monty. All the installation problems would be associated with the simulator package, not the Monty package.
Wait, is the capabilities paper, the flops there, were they including the simulator in the numbers?
No.
Okay.
No, but it took months of work to do that because simulator and Monty were in the same spot.
Okay, so yeah.
So we came a bespoke instrumentation of all of Monty versus just run perf on Monty's process.
Okay, yeah.
So installation problems would be associated with Habitat Sim versus Monty. Someone else could write a simulator that works in the same way, but it's a different simulator. So it'd be like, it also kind of specifies like an integration point for other people of like, hey, bring your own simulator to Monty, as long as you're meeting the simulator protocol. And you have an example of how a different simulator works. And then we also want to do this as part of our, this is also part of our platform 1.0 roadmap anyway. So
Sold me.
Yeah, sounds pretty good.
Yeah. That darn habitat. I think it's back everywhere.
To the discussion this morning, is there any reason it's like a security concern when Python's support lapses as well for people to like install tpp.monty?
like I'm trying to figure out how to not have the wrong conversation about this. Because when I don't want to have to justify upgrading because there's a problem. When we're not upgrade, we're missing out on. So this expired. The Python we have is from 2000. What year is that? 2009. Python 3.8.
They have pretty long lifetime.
Python stable.
Mostly it's just embarrassing. But it is the community, it's not embarrassing anymore.
Well, so I think
Here we go. So it was
Small children,
created.
stop laughing at that.
Python 3.8 created was 2019. So
That's not that bad.
So we have missed out on 6 years of new features to the language. So it's not that it's gonna become insecure or whatever else, is we are running 6 years behind. We are building the latest next thing in AI, and we are using technologies from 2019 before ChatGPT-5 existed. Like it's a hard sell to me. All the other thing is, because we're using an old version of Python, all the libraries we're using are now going obsolete. So now NumPy, we are NumPy version 1. The reason we are NumPy version 1 because NumPy version 2 doesn't support Python 3.8. So now we can't upgrade to NumPy 2. And it's like, well, do we ever need to upgrade? It's like, at a certain point, people will not be able to install Monty because it was going to be old crap that nobody knows how to run anymore. This is the life of software. It's like we always have to update it. So it's always.
Yeah, to be clear, I'm not arguing against upgrading it. I just thought maybe it's another benefit.
Yeah, I mean, for this project, it's less a security issue because you're not running anything in production that someone can attack constantly.
Yeah.
It's more that, like, is it supported?
Yeah,
is there stuff, is libraries supporting it?
What is the user experience almost?
Yeah.
Like,
I mean, especially like as you get further along and distributions of Linux and stuff like that start removing older versions of Python, like they're probably going to remove 3.8 already.
Yeah.
And then you can't even install it without like building it from source or whatever.
Yeah, well.
Right. So.
Yeah, because an installation problem. As soon as you go obsolete, then any new platform that comes after that feels not obligated to include it because it's obsoleted, and so you rapidly become uninstallable by anybody who has anything modern.
Yeah. Lots of excellent reasons.
Yeah.
Cool. Okay, implement testbed for compositional objects. So Vivian had added this one to the list, but I can pitch it. So we all know compositional objects is something we care a lot about. It's what we've been kind of gunning for a while, but we actually need a way to evaluate it and see how we perform on it. We talked about this last Wednesday. There's a few ways we could approach this, but Omniglot seems like a really good candidate for a variety of reasons. It would allow us to test that we can kind of have stacked learning modules that are representing different kind of parts of objects as well as these compositional objects. But it would also enable us to, see if we can improve Monty's performance on Omniglot. That's a very challenging data set still in machine learning because you have an extremely small amount of data to learn from. People in the community are interested in how we do on these more traditional machine learning benchmarks. And although we have lots of good reasons for not evaluating on MNIST and things like that, but actually Omniglot is a pretty good match for Monty because, again, of the size of the data set, but also because it has actual like movement information about how people were kind of moving their cursor as they were writing these letters. So it would just be a great data set to evaluate this. And it means after the hackathon, we could kind of go back into September armed with this benchmark and kind of tick off some of these really nice things that like Scott and Rami have been working on with, for example, the hypothesis resetting and the policies, and actually see how those perform. I think it's also a cool project because there's kind of scopes expanded further. So one of the other projects you'll hear about in a bit is about having these 2D sensor modules that kind of are specialized for processing kind of textures and logos and things like that. If someone works on that and makes progress on that, there's scope at the end of the week to try and combine them and then say, okay, well, can we now do the logo on mugs data set and things like that? So there's a lot that we could do with it.
So then part of it would be to also set up the logo on the mug data set?
I don't think that should be a starting goal, but it could be something to try. The other thing I did mention was, as part of this would be coming up with evaluation metrics and implementing those in Monty. So yeah, we talked about, for example, how this kind of prediction error is a really good way we can look at how well Monty is modeling the world without having supervised labels, because as we go into the future, we're going to have less and less access to kind of supervised information about the world and what Monty is seeing. And so one of the only ways we'll have to measure its performance is like how accurate is it predicting the world. And so this would be one of our, I think, our first measure looking directly at that.
Yeah, I guess if it becomes a 2 or 3 person team, one person could work on the logos and marks data set, another on the Omniglot, and another on performance measures.
That's true, yeah.
Because like Omniglot will not be a good data set to test policies, for example.
Right.
But since Omniglot is already pretty much set up and mostly requires like evaluation metrics,
yeah,
it sounds like it could be so reasonably within scope to kind of try both.
That's true. Yes.
Yeah. And I guess just to give a bit of context with compositional, being able to model compositional objects is again one of these huge milestones that will unlock so many more capabilities or applications for Monty. Like before it can model objects in a void. Even if it's a compositional object, it models it as like one large thing. With it, we can deal with like pretty much every application has like some background and different objects within a scene. So we can then deal with that. Plus, we can more efficiently model things by decomposing them into different parts. So yeah, it's like a huge capability to add to Monty. So huge benefit.
Cool. Any questions? What was the next one?
Bounded evidence EMA neurons, Rami.
Yeah, I could pitch this one. So the reason for this one only came about last week when I faced some problems with just using the raw evidence, accumulated evidence scores, and these are unbounded. They could just go, they could keep increasing. We've seen evidence go 50, 100, whatever. And there are a lot of problems, like when you're trying to define some formulas or like just mathematically understanding what's going on. It's very difficult to work with these unbounded evidence scores. One approach that I took was just to divide the evidence score by the number of steps the hypothesis has taken, or like the age of the hypothesis. And while this seems to work, it's not very much biologically plausible. It's probably not the way we want to go. Niels had suggested some different approaches that are like more like like a neuron's membrane, like membrane potential, where it would decay if it didn't get enough evidence and things like that. And I think this project would be more of an investigation into how to make neurons more, like how to make the evidence more biologically plausible, similar to how neurons do it in a way that it would decay and increase exponentially, like it also like plateau when we increase it. So it would be bounded between like 0 and 1 or -1 and 1. And we would basically be using something like EMA, exponential moving average or something like that, so that we could get the same effect of that bounded evidence. So basically, I think what we're thinking here is that neurons will basically be supported by evidence. So as they plateau towards 1, they will keep, if they're getting evidence, they'll just be getting closer and closer to 1, but they're going to be tapering off at 1. But then if they don't get evidence, they will start to decay, just like the membrane potential will decay if it doesn't get spikes. The difference here is that I think the integrate and fire model, all of the integrate and fire models, they just keep integrating, the charges that as spikes, so they keep adding them. They're not really bounded. They are bounded by the threshold, so when they fire, they just go back down. So we just have to think about how much biological plausibility we want here and how to compare it to existing neuron models and what benefit we'd get from that and all of these nice things.
Yeah.
Yeah, I guess that's it. If you, Niels, have anything else to add.
Yeah, I was just thinking, I can quickly draw. So I feel like there's a few cool things about this, because this is like Vivian had already kind of added some parameters that if you select the right parameters, it is an exponential moving average. And so we've already kind of experimented with a bit. So it's like we were already and kind of thinking, oh, we should probably go back towards that. Like it seems better. Not really thinking about the biology that much. And then
about it.
Okay. Yeah, sorry, no, that's true. Like as in like that it was bounded and stuff.
Yeah,
but like
I was thinking about it, implemented it, it didn't work well yet.
Right.
Because we don't have efficient policies. So I think
Right.
after we have the efficient policies, it should work much better.
But then at the same time, Rami, you implemented this like slope tracker, which was like an independent measure of kind of evidence that we had. And what's kind of interesting is neurons will have what do you call it? Different compartments. Oh yeah, sure, thanks. So okay, firstly, like,
Can you see that?
Not really, but that's fine.
Yeah, I can hold it there.
or we can take it over because yeah, Anyway, so this is the membrane potential of the neuron. Like as Remy was saying, as you get kind of like incoming spikes, it goes up and it kind of accumulates that. But let's say you stop giving any spikes, it'll decay down. And if it hits a threshold, then it has its own kind of discharge. But this kind of behavior is not exactly modeled by an exponential moving average, but it's very close. And I feel like exponential moving average is like a nice, because having networks that use integrated fire neurons is notoriously difficult to train and learn with. But we basically know already that exponential moving average would work pretty well. Like you say, it's just we need good policies and stuff like that so that we move around enough. And then in addition, when people model integrated fire neurons, they tend to model neurons as point neurons. So they treat this entire complex structure as a single dot getting inputs and having an output. But the dendritic compartments are totally ignored. And that's where Numenta was unique for coming up. And then you can have multi-compartmental neurons where you simulate all of this. But those are even more complicated and like really hard to train to do anything interesting. Numenta was unique because HDM neurons kind of approximate a bit of a point neuron and a multi-compartmental neuron. If we did an EMA neuron and we had the slope tracker, that would potentially be doing something like modeling the soma, and our old evidence count with EMA would be kind of modeling the dendritic compartments, because these have, when they spike, they have a much longer time constant where even if you don't get further input, it stays up for much longer. Whereas the soma, it's a bit more like it depends on what's coming in at that moment in time. And neurons kind of integrate those two. So it's just kind of interesting that, I don't know, all these different things are kind of converging on what it seems the brain is doing, or what kind of neurons are doing. And then part of this week would be, as well as implementing this, kind of thinking through some of those consequences. Because like one thing is, yeah, as Rami said, we don't currently have spiking. We've talked about how as we move towards unsupervised learning, we want to have some sense of like, okay, these columns are coactive a lot, so we need to associate them. So if we actually start having spikes and measuring that, like that would be a natural way of counting that kind of co-occurrence and things like that. So it could have some kind of interesting implications. I think it would be exciting for the community. Like I think they would be really interested to see us kind of having a neuron-like model. And I mean, we already kind of had something similar, but I think it turns some people off when we say, oh, it's evidence count, and kind of it's not clear that there's that connection to the biology. I think we can make that much clearer here while still not restricting ourselves by trying to kind of simulate the brain.
Most of the implementation, so you take the existing implementation of EMA,
yeah,
and then add EMA for the slope tracker,
yeah,
and then test parameters of how to set the parameters for hypothesis adding and deletion,
yeah,
and then see how well it works.
Yeah, and then there might be kind of a bit of like theory side of just like, let's try to think through some of the other implications, like the multi-compartmental stuff and the spiking, and if there's anything else that like we don't necessarily need to implement this week, but are worth kind of having on the roadmap of like, oh yeah, we need to do unsupervised learning. Now we have our EMA neurons, they're bounded. Let's add in spiking and start counting these, and then and see how that works.
Yeah, I guess my main concern with it is that if we already had the efficient policies, that would be great to do now. But now it will run into the same issues I ran into 3 years ago, and it will not work well, and then it will be like discouraging, and you will not really be able to test the new mechanisms. But we still have that issue.
In theory, if you set this time constant for the background evidence long enough, at the limit, it becomes equivalent to the current one. So
I don't think so, because you'll have very low resolution if you set the pass weight very high compared to the current weight. Then you have to work on like the not one thresholds kind of thing.
Yeah,
that's it, and you have to adjust that the longer the episode goes and stuff like that.
Yeah, but then I guess all of them would be struggling with that. So it'd be like everything was kind of normalized the same.
Yeah.
But yeah, it might be an issue. But yeah.
Yeah, we can. Yeah.
So that's the project.
Yeah,
that's the project.
Okay. All right. Next up is Monty flame graphs. So this is just building a quick prototype of making sure we can use flame graphs with Monty in an easy way. Basically, every time you run an experiment, you can get a picture of a flame graph to see where Monty spends its time. So this is Perf is standard tooling in the industry. Flame graphs are standard tooling in the industry. So there's no invention here. It's figuring out just the happy path for all of us to get those visualizations out of Monty. The benefit for the community is it becomes kind of trivial to rapidly identify the bottlenecks of wherever Monty spends most of his time. So if anybody cares about performance optimization, etc., they could look at a flame graph, see where the most time is spent, and be like, okay, we're gonna fix that. And
Especially if they're trying to do robotics in the real world, that and you're trying to keep up with the world.
Right.
Be especially interested in where Monty's spending his time.
yeah, so just having a story, just like a tutorial of like, here's how you get flame graphs. And the other thing, that feedback loop is super helpful in making effective changes without just guessing and hoping for the best. So you can rapidly like hill climb to really good performance using this type of tool.
What's the advantage of the existing profiler? It's just easier to use, or
Anytime you add some new code, like you have to update your profiler. Like perf just works with any Python code.
the profiler too, I think. We're not integrating it specifically. It's just a mix-in for the experiment class, and then it,
Yeah, but it's wrappers around all those methods. If we add methods and stuff like that, you have to remember to go and add those wrappers as well, right? Whereas with perf, it just picks it up from the interpreter.
Like perf works at a Python level, so like no, like I don't have to change any. I don't have to remember to turn it on. I run it with the perf tool, and it instruments the language itself, and function calls inside the language. Like there's
that's what the profiler does too. I never had to change anything when code base changed. It just profiles how long you spend on each function call. But maybe I'm missing something. I don't know. Like whenever I used the profiler, I just added that.
why didn't we use that for floppy? Why do we write floppy instead of using the profiler?
I thought the
I think
profiler was
quantifies
just for
flops.
count like the seconds you spent on each, not for counting flops.
Okay. Seconds
Or
or
milliseconds. So
Okay.
like the time
Like,
spent
so
on
walk-
each function.
so
is the
it tests walk clock time.
Yeah.
the flame graphs don't do walk clock time, they just do
Flops or
time. Like on CPU instructions, like how much it takes.
okay, I'm not sure which one the profiler currently measures, but it was definitely time spent on each function.
Yeah, I mean, that's generally what you're going to do with profiling. Like flops is sort of very specific to mathematical operations, right?
Yeah,
Yeah.
and even kind of like deep learning, it's sort of become like a thing that they focus a lot on.
Yeah, it's
but
doing a lot of
it's-
floating point operations.
But generally, you don't like you care about these other things, not flops, because it's so dependent on what hardware you have, implementation, and all this stuff.
Yeah, I mean, I agree the profiler is probably more tedious than this because you get like a large Excel spreadsheet and then you have to analyze it. Whereas this sounds like you get like a nice visual representation of it. But yeah, I guess just wondering if there are other benefits.
I mean, part of it's you're using it's standard tooling versus bespoke tooling. That's mine. You can use the stuff that's built for using perf data to turn flame graphs and those things.
The profiler is also just some library we import.
Okay.
You have to rewrite anything to use that. You said it was a mix-in. Like,
Yeah, it's
you have
just
to-
an experiment class mix-in. It's just like I think it's a standard Python profiler library. You import it.
So it wraps around like the whole experiment kind of.
Yeah, you just use the profile experiment mix-in in your experiment config, and then it takes much longer to run your experiment, and at the end of it you get like a spreadsheet with how long you spent on each function.
So the other thing with perf is nothing takes longer. Like it's just the data is collected out of band by the operating system.
Okay.
So this is the thing about like if you run perf, there's no performance overhead.
Yeah.
All the data is collected out of band by the Linux kernel.
Okay.
Versus this stuff is like this is what I mean. Difference between adding more Python to measure Python versus the kernel intercepting calls at a kernel level.
And so it sounds like for the same reason it's very like incredibly simple to set up. Like even the first time.
Just put the word perf in front of your thing.
Yeah.
Some flags.
Have it
Yeah,
installed.
perf is what we use like in AWS, like to compare with floppy, if you remember. Nils? Yeah.
Yeah, good.
Yeah, I think the only, at least in our AWS, like besides just adding like perf and then Python run, whatever, it was like there was some security, like we had to set the level, some
Right. I remember you saying,
yeah, some paranoid level to like not very paranoid, but besides that, yeah.
Yeah, so we are using C profile library for the profiling.
But yeah, I guess that's another advantage if the perf can also look at flops. If we ever want to look at that again.
Okay, cool. Yeah, next project.
Implementing sensor module.
you want me to do that?
Yeah, maybe.
Yeah,
Yeah,
please.
so that way you can relax, OJ.
Yes, please. Thank you.
Okay, so yeah, implementing 2D sensor module has several benefits. Well, let me start with what it is. Basically, the idea is to have a sensor module that's specifically designed to both output movement in 2D space, so basically how you're moving on the surface of an object versus how you're moving in 3D space, plus detecting 2D features on that surface. So basically, instead of the sensor telling you you're moving in 3D space like this, it will tell you, oh, on the surface of this object, you're moving up, down, left, right. And I'm detecting like an edge here instead of saying I'm detecting like a point normal and curvature direction here, because there might not be any curvature directions. Like if you're on a flat surface, you want to define the orientation you're sensing there by like the edge that's printed on here, for example. And so that's important generally if you're dealing with 2D data sets. Like I implemented something basic for that when we did the ultrasound project, because we got 2D images. You could probably use some code from that for the kind of edge detection and curvature extraction. And then specifically in the context of compositional objects, this would be useful to model the logo, which is inherently like a 2D model, being wrapped around a variety of three-dimensional structures, because if you're just looking at how you're moving on the surface of those structures, it will be consistent with the logo model that was learned in 2D, even though your sensor is moving around like a curve or something. The 2D sensor module would represent it the same way as if it was moving on a flat surface. So yeah, I guess the outcome of the project would be a new sensor module class that outputs 2D movement on surface, plus features detected on that 2D image.
Salience Showdown, Scott.
Okay, I don't think I've got the energy to go cowboy on this one. So I think everybody is kind of familiar based on like research meetings probably, but you know, this project that I've been working on, I'm just trying to recruit somebody to help me with it selfishly. But the basic idea is like, this is a vision-oriented project where if you look at, can I grab this?
Yeah, please.
If I pick up this bottle, I'm trying to recognize it. I'm not just going to randomly move my eyes across to any point on this bottle, which is what Monty does right now. It's going to try to, in a very low-level way, find the points that are most sort of significant or salient, and then just immediately attend to those. And then after a few of those, I should be able to more quickly identify what the object is. And it doesn't require any memory about objects it's seen or anything like that. So it's not like this model-based jump, which is kind of another topic to get into. So this is a model-free strategy, and I would say there's like I've got like a pretty good fork right now that's like ready to go. And so the idea was essentially anybody who wants to work on it, you should be able to, after maybe a day's work or so, just drop in any kind of function that'll just like take an image out, and from that image output a scalar for each pixel and say, oh, that's a place I want to look at, that's a place I want to look at, and that's a place I want to look at. And so in principle, you could spend a week just trying to find the function, find functions that will, most efficient, and then make it a little test bed, which it already works for the YCB data set, but we can make use existing benchmarks or some maybe smaller ones so we can do it faster. So you should be able to drop your function in, run the benchmark, see how well it did, like what was our performance improvement in terms of the steps, because that's what we're trying to reduce here. And so that's the basic idea of the project. I think it's the preliminary work to get this project is there, and so I think it would be pretty easy to drop in, and I would say this is also a project that could work pretty asynchronously for most of the week. For remote people, it could work well. There would be like a little bit of early setup to figure out how to get my fork going, and maybe setting up benchmarks and stuff that would be good to do together probably. But beyond that, it's like, here's my function, drop it in, try it, go. We can kind of just check in and compare whenever. So that's my pitch.
Cool.
If y'all are good with
I
that.
said this, sorry, but yeah, it should be possible in terms of evaluating, just use the standard YCB objects now.
Yes.
Yeah. So then, that's perfect.
Yeah.
So are you competing with the person on your team, or?
I think the competition would be who like what is the best algorithm?
Yeah.
And if you want to make it personal, then yeah, have at it. Okay, so I guess the other sort of addition to this is like Vivian, as you're talking about objects behavior, salience traditionally like in animals involves motion. So having a nice experience working with salience could be nice for helping out with that eventually when maybe we want to attend to the parts of the scene that are moving for object behavior or something like that.
And also
So it kinda ties
recognizing
into that.
objects quickly if they're moving.
Yep.
It's important.
Yeah.
Yeah. It's so
Yeah, it's hard to
there's
go-
kind of a lot of like little bits like
Right.
in other projects where it'd be kind of nice to have even if we don't build it out right now, like the particular implementation that's going to work with motion or whatever, but getting some kind of development on that project would be good.
Okay, was that the last one?
Well, I think Will added one.
Yeah, I added one more,
All right.
which is really just an excuse to show a video of Tristan. Thanks.
Can you guys on the call still hear me?
Yep.
All right, awesome. So yes, this one's called Interpretive Dance of the Neuron. And it's essentially the output of this project is each member of the TPP staff using a neuron and doing an interpretive dance of that neuron. I think this would in no way. So it probably won't be chosen.
That's by entertainment.
Yeah, us by entertainment. Let me give you a quick example of what that might look like. If I can figure out how to share sound. All right, here we go. Share. And here we go.
Where did you put it?
Not actually Bella Kid, but there we go.
Great. Yeah, I'm sold.
I did get permission.
Brain jingle. Get an AI model to make a brain jingle. And,
We can go viral.
Yeah.
TPP team officially lose their minds in Brighton.